Hi, and welcome to Dr. Vanderveen's AP Chemistry Podcast. Tonight we're talking about titration problems. Titrations, as you recall, are a type of solution stoichiometry problem, and we're going to stick mostly with acid-base titrations, but there are actually other kinds of titrations, such as redox titrations. So our objectives for this podcast, we want to review some solution stoichiometry, go over some key points, make sure you're comfortable with how these problems work, and then actually go through some practice problems so you can see what types of things you need to be able to do, what kinds of skills you need to practice. All right, these titration problems are often done to find the concentration. That's probably the most common type of titration problem, but of course there are other things we need to be able to do with titration problems. So you will sometimes end up having to calculate masses, or sometimes you may need to calculate molar masses of an unknown. So that's the other main type of problem that come up in titration problems. You need to start with a balanced equation when you're doing a titration problem. It is really a stoichiometry problem. All right, so you should be able to generate a balanced equation. You certainly need to know the mole-to-mole ratio of the reactants, and that can simplify things for you in certain problems. There may actually be shortcuts, and we'll talk about that. What you need to realize is if it's an acid-base titration, let me add that in. If you have an acid-base titration, the moles of acid added will equal the moles of base added. All right. If they react in a 1-to-1 ratio, if you know that it's a 1-to-1 ratio, then you can use this very handy equation, M1V1 equals M2V2, and this comes in handy for lots of solution stoichiometry problems if you've got that 1-to-1 ratio. There are ways to adapt it, but I don't really want to go into that right now. You can also work from the molarity formula and mole ratios to solve these problems, but the M1V1 equals M2V2 comes in handy for a lot of circumstances, and if you know that, and you know it applies, go ahead and use it. All right, so that's especially true for monoprotic acids with hydroxide bases that only contain one hydroxide in the formula. So they react in a 1-to-1 ratio. So let's look at a problem where this actually is true. So we have here chloric acid. What volume of 0.342 molar chloric acid solution is needed to completely neutralize 45 milliliters of 0.109 molar KOH, potassium hydroxide? Well, this is a monoprotic acid. It's only got one hydrogen in the formula. It's reacting with a hydroxide base that only contains one hydroxide. So these do react in that 1-to-1 ratio, which means we can easily use the formula M1V1 equals M2V2. Or you may have seen it expressed as MAVA equals MBVB. It's all the same. It doesn't really matter. So we had 0.342 molar chloric acid. We want to know its volume. All right. We can work with milliliters as long as your units are the same on both sides. It doesn't really matter what concentration unit you're using or what volume unit you're using. And we had 45.00 milliliters of 0.109 molar KOH. And what this is saying really is at the end point, the number of moles of acid, because this will work out to be moles of chloric acid, are equal to the moles of base. And that's really the origin of this formula. We're just setting them, and they're in a 1-to-1 ratio, so this works out very well. So let's get out our calculator. You might want to rearrange the equation before you get too far, but really this works out pretty well. So 45 times 0.109 divided by 0.342 comes out to be I get 14.342 105 on my calculator, but you'll notice we have 3 sig figs here, 4 sig figs here, 3 sig figs here, so we want to record our answer with 3 significant figures because that's the appropriate way to write this. So the final answer is 14.3 milliliters of chloric acid. So this is a pretty simple titration problem. You're in a 1-to-1 ratio, and you just could apply the equation. And in this podcast, I'm not even going to go to a more complicated example. We're going to stick with the simple ones right now. Maybe I'll do that in a subsequent podcast. The second problem is a little more advanced. This is a little bit more like an AP level problem. All right. We have 32.5 milliliters of 0.116 molar sodium hydroxide. And that's how much base is needed to neutralize a solution containing 2.5 grams of an unknown monoprotic acid. We don't even know what acid it is. We know that it's monoprotic. We'll just call it HA. And our question says, calculate the molar mass of the monoprotic acid. These actually work out to be pretty easy. They're not too bad. What we can do is we can say, well, gee, moles of base equal moles of acid. And so we can calculate the moles of base easily because we know from the molarity formula, since the molarity formula is moles over liters, we can say the moles of base is equal to the molarity of the base solution times the volume of the base solution in liters. All right, so we had a 0.116 molar solution, and we had, I better convert this before I put it in, 32.5 divided by 1,000, 0.0325 liters of base. I'm really bad at doing those conversions in my head. I always end up having to check them. 0.0325 liters. So hopefully you won't have that problem. You can just go straight to the conversion. Times 0.116. So I get, for the moles of NaOH, 0.0377 moles of NaOH were used to titrate the unknown acid. Well, we can therefore say that we have 0.00377 moles of acid, which I'm just going to call HA because I don't know what the formula is. We also know that moles is equal to the number of grams divided by the molar mass. And so we can rearrange this equation here to solve for the molar mass because we know the grams and we just found the moles. So the molar mass of the unknown acid, if we rearrange, is equal to the grams of the acid over the moles. We happen to have both of these, so this is not a problem. So we had 2.5 grams, we were given that in the problem, divided by the total number of moles that we just found, which was 0.00377 moles. And we're going to do the calculation. 2.5 divided by 0.00377. And we get a number. And remember, we can only have 2 significant figures. And we say that because 2.5 grams hit 2 significant figures. So I get an answer of 660 grams per mole for the molar mass of the unknown acid. And this is a very typical problem. You want to be able to do this. You want to practice problems like this. And you should have good success with these. And we'll talk another time.